Hello everyone. Today we're going to do angular values of trigonometric functions, class 11, CBSE and ISE. The first portions is the radian measures, which I've already made a video. This is our second lesson where we need to find the angular values of trigonometric functions. We know some standard angular values like 30, 60, 45, 90 and all this. This year we're going to learn many other angles. Now first thing to learn for this is to see the signs of trigonometric functions. We have to learn the signs of trigonometric functions first. Now I've drawn an x and y axis here. Let's consider a right angle triangle in the first quadrant. Let's consider a right angle triangle in the first quadrant where the angle theta is here. So we know that x would be this to this length, isn't it? And this is 1. And assume it's part of a unit circle. So it's part of a unit circle. So the AC forms the radius, which is 1. So when I say unit circle, radius equals to 1 unit. Alright. Now, this will help us to understand the sign more clearly. So we consider this is a right angle triangle inside the unit circle. And it lies in the first quadrant. Now, first quadrant, sine theta is y by 1. Cos theta is x by 1. Tan theta is y by x. So that means the first 3 trigonometric functions are positive. Hence, the remaining 3 will also be positive. So all trigonometric functions are positive in the first quadrant. Alright, so we represent it by letter A. Since all trigonometric functions are positive in the first quadrant, we represent that quadrant by letter A. Now let us consider a right angle triangle in the second quadrant. In the second quadrant, angle theta is here. This is y and this is minus x. So this to this length is minus x and its y, hypotenuse is 1. So sine theta over here is y by 1. Cos theta over here is minus x by 1. Tan theta over here is y by minus x. So that means only sine is positive, cos and tan are negative. If sine is positive, the reciprocal of sine, cosec, will also be positive. Isn't it or not? If sine theta is y by 1, cosec theta is 1 by y. If cos theta is minus x by 1, sec theta will be 1 by minus x. Likewise, if tan theta is y by minus x, cot theta is minus x by y. So when sine is positive, it is apparently cosec will also be positive. All the other trigonometric functions are negative here. So let's represent this quadrant by letter S. S because sine and cosec positive in the second quadrant. Now let's consider the right angle triangle is in the third quadrant. Let's consider the right angle triangle is in the third quadrant. Theta, x is, this is minus x and this one is minus y. So sine theta here will be minus y by 1. Cos theta will be minus x by 1. And tan theta will be minus y by minus x, which is y by x. So that means sine cosec negative, tan positive. If tan is positive, then cot is also positive. right? So in third quadrant, only tan and cot are positive. So we represent this quadrant by letter T. We represent the third quadrant by letter T. Now let's consider the right angle triangle is formed in the fourth quadrant. Theta x, AB is x, and this length is minus y. So sine theta over here is minus y by 1. Cos theta is x by 1. Tan theta is minus y by x. So that means cos is only positive here, which means sec is also positive. So in the fourth quadrant, only cos and sec positive. So we represent this quadrant by letters C. We are not discussing the angles, we are discussing only the signs of the trigonometric functions. So in a nutshell, if it's four quadrant, first quadrant is represented by A, second quadrant is represented by S, third quadrant is represented by T, fourth quadrant is represented by C. All school to college. Or add sugar to coffee. These are the shortcuts to memorize the pattern, ASTC. So this is how we decide on the signs of the trigonometric functions. But uniformly I took the angle as theta. There is something to learn about the angle also. So first thing is the signs. I think you are all thorough with that. Now let me take you to the angles next. Now we are going to discuss the angles. We first saw the signs of the trigonometric functions. Now we are going to discuss the angles. If the given angle is above 90, because 0, 90 degree, 180, 270 degree, and here it is 360. So one full rotation. Alright, 0 to 360. Now if the given angle is below 90 degree, a given angle is 90 minus, if the given angle is below 90 degree, so all 90 minus theta angles falls in the first quadrant. All angles less than 90 falls in the first quadrant. All angle above 90 below 180 falls in the second quadrant. All angles above 90 below 180 falls in the second quadrant. All angles above 180 and below 270 falls in the third quadrant. And all angle above 270 below 360 falls in the fourth quadrant. So we divided the two-dimensional space into four quadrants, a plane into four. The first quadrant contains angles that are below 90 degree. Second quadrants contain angles above 90 below 180. Third quadrant contain angle above 180 below 270. Fourth contain above 270 below 360. Now what happens to any angle that is above 360? Well, that is considered as a second rotation. Alright, so this is for one rotation. Now the next thing that we need to be sure is about the conversion. Do you remember the complementary angles that you've learned in 10th grade? Sin 90 minus theta is cos theta. Cos 90 minus theta, complementary angle theory. Complementary angles. Sin 90 minus theta is cos theta and vice versa. Sec 90 minus theta is cosecant theta, vice versa. Cot 90 minus theta is tan theta, isn't it? So using this, so therefore sine will convert to cos, cosec will convert to sec, or sec will convert to cosec, cot to tan if the angles is in their, if the angles are in the complementary form. Now what is complementary? 90. Now here we are not only discussing angles below 90, we will also discuss angles above 90 also. So angles which are in the odd multiples of 90, like 90, 270, etc. That is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, etc. In all these, complementary angles get, complementary theorem get applied, which means sine get converted to cos, or cos get converted to sine. Cosec get converted to sec, and sec get converted to cosec, vice versa. Tan get converted to cot, or cot to tan. Alright, so if a given angle is above 180 below 360, above 180 below 270, then it lies in the third quadrant. Now if you want to express that angle as 180 plus or 270 minus, then that is where you need to concentrate. If you're using 270, then you have to apply the complementary theorem. But if you use 180 or 360, you don't have to use the complementary theorem. So let me discuss these rules once again to you in short. So how do you find angular values of trigonometry function? Finding angular values of trigonometric functions. Steps to follow. First step, find out which quadrant the given angle lies. Find out which quadrant the given angle lie. Step 2. Find out whether the given angle function is positive or negative in the above found quadrant. Now once you find where it lies, say if they give 120 degree, it is obvious that the angle is above 90 but below 180, so it lies in the second quadrant. Say the angle is 190, then it is above 180, below 270, then it is in the third quadrant. So find out which quadrant the angle lies. After you figure that out, find out whether the given trigonometric function is positive or negative in the above found quadrant. In the above found quadrant. I'll give you an example to understand this. Let's assume they want us to find the value of sine 120 degree. First, I'll see only the angle. 120 lies where? 120 lies in the second quadrant. And what is a letter that we use to represent second quadrant? Yes, isn't it? Yes letter. Yes stands for sine and cosec. Sine is positive in the second quadrant, therefore cosec is also positive. So here it is sine of 120. So the answer of this will be definitely positive. Okay, so we understood these two using the first two steps. Now the third step. Express or split the given angle in one of these forms. Split the given angle. Split the given angle. Now, how do you split and what are the many forms? Like if you know that lies in the second quadrant, then the split up can be 90 plus theta. If it is in the second quadrant, then I can split either as 90 plus theta or 180 minus theta. If the angle is in the third quadrant, then I can split that as 180 plus theta or 270 minus theta. If I find that the angle is in the fourth quadrant, then I'll split it as 270 plus theta or 360 minus theta. So I'll use one of the option to split the angle. Okay. Now after I split it, if I'm splitting using the odd multiples of 90, so that means if I'm using 90 or 270, whether it's 90 plus or 90 minus, whether it's 270 minus or 270 plus, that doesn't matter. The complementary theorem will get applied. But if I'm splitting using 180 or 360, then no complementary theorem. So if it is a sine function, the answer will also be in sine form. But if it's a cos function, it will be a cos form. But if it's a odd multiples of 90, that's in the 90 or 270 form, sine will turn to cos form and cos to sine form. All right? Okay. So these are the three steps that we need to follow. Now let's consider one or two example sums to understand this better. Let's assume it is sine 135 degree. Step 1 is to find where this 135 degree lies. 135 degree lies in the second quadrant, isn't it? Because it is above 90, below 180. It lies in the second quadrant. So step 1 fulfilled. Step 2. What happens in that quadrant to sine? Second quadrant, it is denoted by letter S. So that means sine function is positive over there. It's positive over there, isn't it? Step 3. How am I going to split this 135 degree? Since it lies in the second quadrant, I can split that either in the form of 90 plus theta or in the form of 180 minus theta. Chalo. Now, if I use 90 plus theta, what do I get? Sine 135 degree, I will write it as sine 90 plus 45. Sine 90 plus 45. Sine 90 plus 45. 90 means odd multiples of 90, isn't it? The complementary theorem will get applied. So sine will change to cos. And since it's positive in the first quadrant, it's cos 45 degree. And the answer is 1 by root 2. Now, in case if I opt to split using 180, then I'll write sine 135 degree as sine 180 minus 45. 180 means no complementary and all. So sine comes as sine itself and 45 degree. So both ways, the end answer will be the same. Alright. So few more examples to understand this better. So cos 210 degree. 210 degree lies in which quadrant? It's above 180, below 270, isn't it? So that means it lies in the third quadrant. Third quadrant, what are the angles we have? Third quadrant, we can express them as 270 minus theta or 180 plus theta. Right? Okay. So cos 210 can be written as cos 180 plus 30 degree. Cos 180 plus 30. And it lies in the third quadrant, so where cos is negative. So the answer will be minus. Since it's 180 degree, there is no change to the function, so my answer will be cos 30 itself, which is minus root 3 by 2. Now imagine if I'm splitting this using 270 degree. So cos 270 minus 60. What happens to cos in the third quadrant? Negative. And 270 means change. So cos will change to sine because it's complementary. And therefore I get sine 60. And sine 60 value root 3 by 2. So the answer is same in both cases. One more question. Tan 330 degree. Which 330 lies in which quadrant? 330 lies in the fourth quadrant because it is above 270 and less than 360. And there we have in the fourth quadrant, we have angle above 270 and below 360. So I'm going to express tan 330 as tan 360 minus 30. So that means in the fourth quadrant, tan is negative. So it's minus. 360 means no change. So I get tan 30 as the answer. So answer will be minus 1 by root 3. Now imagine I'm going to split it in the other way around. So I'm going to take tan 330 as tan 270 plus 60. Now, anyway, in the fourth quadrant, tan is negative, so answer have to be negative. 270 means change. So tan will change to cot. So I get cot 60. And cot 60 is what? 1 by root 3. So answer is minus 1 by root 3. Therefore, we get the answer C. So what do we do now? When an angle is given, first when a trigonometric function with an angle given, first we see only the angle, we locate in which quadrant the angle lie, then we will think about the sign that respective trigonometry function carries in that quadrant, and then we split the angle using the split up in the quadrant, and then we give out an answer. Whatever way we split, the answer will be the same. Hope you understood this. If there is any doubt, drop it in the comment box. Thank you.